Yes, welcome to my lecture number 2. Today I am going to talk about the additive rule and its related problems. Before talking about the subject, I will introduce myself. My name is Dr. P. Venkat Raman, working as Professor of Mathematics in Freshman Engineering, Marri Laxman Reddy Institute of Technology and Management, Hyderabad. Additive rule. Additive rule theorem is state and prove additive theorem on probability. Now, what is a statement? First, we know the statement of the additive theorem. So, what is a statement? Suppose A, B are any two events in a sample space, yes. In a sample space, yes. Then probability of A union B equal probability of A plus probability of B minus probability of A intersection B. So probability of A union B, union represents R, intersection represents AND. So here probability of A union B equal probability of A plus probability of B minus probability of A intersection B. Okay, this is the statement of the additive rule. So here now how to prove this theorem? Proof of this theorem. Now I will explain this theorem by taking Venn diagrams, because pictorial notations are always easier than the documentation. So that's why I will explain this theorem by using Venn diagrams. Suppose this is set A and let this is set B, and this part is the intersection of A and B, and we denote this by A intersection B. Here A, B both are the not disjoint sets. Not disjoint sets means they are disjointing and they are intersecting. So here intersection part is A intersection B. Now from this Venn diagram we can write that number of A union B equal, here number means here A union B, this area and this area plus this area also. This all together number of A union B is equal to, we can write number of elements in A plus number of elements in B. So here what happened? Number of elements in A one set and number of elements in B again. So here A intersection is repeating two times. Number of elements A plus number of elements B. So here A intersection B is repeating two times. So that's why I will subtract the number of elements in A intersection B one time. Okay. Now then here number of elements in A plus number of elements in B. So I subtracted one intersection A intersection B. So then finally I will get the A union B. So this is very, very important step I have written from the Venn diagram. Now here, so what happened from this? Now I divide this equation by n of s. Now here what is n of s? Number of elements in sample space. Now I will take this as like this. Now this total is sample space, yes. Now n of s represents the number of elements in S. N of A union B represents the number of elements in A union B. N of A represents the number of elements in A, complete A set or A event. And plus N of B means number of elements in B set minus number of elements in A intersection B. Now divide this entire equation by n of s, then I will get like this. N of s and this by n of s, and this by n of s, and this by n of s. Okay. Now you call it as equation 1. But from probability definition, what we know that probability of event E equal n of E by n of S. Here n of E means number of elements in E, event E, divided by number of elements in S, sample space. This is defined as the probability of event E. So you apply this definition of probability on this. So what happened here? We will get probability of A union B equal here n of A by n of S. So therefore this becomes probability of A plus n of B by n of S. This becomes probability of B minus n of A intersection B by n of S. This is the probability of A intersection B. Okay. Now you see we got the statement of the additive rule. What is the statement here? Probability of A union B equal probability of A plus probability of B minus probability of A intersection B. Now this also you can write like this. Now send this intersection part left side and send this union part this side. So what we get? A intersection B equal probability of A plus probability of B minus probability of A union B. This is also another form of the additive rule. Another form of the additive rule. So from these two steps we can conclude that and additive rule is very simple, and we can derive this, proof this theorem or rule by using Venn diagrams. Next, note. So here note, I will give 3 notes. So first one is here, suppose A intersection B equal pi. A intersection B equal pi means AB are disjoint. AB are disjoint and they are not intersecting, separating events A comma B. Then in this case, what do we write here? Probability of A intersection B equal pi, that is 0. Probability of A intersection, probability of pi is equal to what? 0. So therefore, additive rule becomes probability of A union B equal probability of A plus probability of B. So this is the equation when the AB are disjoint events or disjoint sets. Now another second note. Suppose you extend this logic to the 3 sets or 3 events. Then what happened? N of this is probability of A union B union C. 3. Similarly, just you apply probability of A plus probability of B plus probability of C minus probability of A union A intersection B minus probability of A intersection C minus probability of B intersection C plus probability of A intersection B intersection C. Suppose if you have 3 events or 3 sets, then probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. So this is the extension of the additive rule for 3 events. Next, with this background, now we do some problems, and very simple problems. Problem number 1. If probability of A equal 1 by 4, probability of B equal 1 by 2, and probability of A intersection B equal 1 by 8, then find probability of A union B. So now we solve this problem. But here we have to determine probability of A union B. Since additive rule, we have probability of A union B equal probability of A plus probability of B minus probability of A intersection B. Just substitute the values here, given values, then we will get this probability of A is 1 by 4 plus probability of B is 1 by 2 minus this is 1 by 8. Now take LCM here, 8 we will get here 2 and this is 4 and this is 1. So 6 minus 1 by 6, that is 5 by 6. This is the probability of A union B. Okay. Similarly, come to the second problem. In second problem, if probability of A equal 1 by 3, probability of B equal 1 by 4 and probability of A intersection B equal 1 by 12, then find probability of A union B complement. Probability of A union B complement. Okay. So in this also we will use additive rule to find this value. So what is the given data here? Probability of A equal 1 by 3, probability of B equal 1 by 4, probability of A intersection B is 1 by 12. So from the given data, now we write what we need actually, probability of A union B complement. But from the set theory we have complement, we can write 1 minus probability of A union B. But here 1 minus, what is this probability of A union B? You write this value from the additive rule, that is probability of A plus probability of B minus probability of A intersection B. Now substitute the values, 1 minus, what is the probability of A? 1 by 3 plus 1 by 4 minus 1 by 12. Now this becomes 1 minus, now within the bracket value you find out, take LCM here 12, here 4 plus 3 minus 1. So finally what happened? 1 minus this bracket, 4 plus 3 7, 7 minus 1 6, 6 by 12. 6 by 12 means 1 by 2. 1 by 2, so 1 minus 1 by 2. This becomes 1 by 2. 1 by 2 means 0.5. This is the probability of A union B complement. Okay. So it is also one good problem. So we move to the next problem. Problem number 3. If probability of A equal 1 by 4, probability of B is equal to 1 by 2 and probability of A union B is equal to 1 by 8, then find probability of A intersection B, here is asking. But I said another form of the additive rule. What is additive rule? Another form, probability of A intersection B equal probability of A plus probability of B minus probability of A union B. So that we can write solution here. We can write as probability of A intersection B equal probability of A plus probability of B minus probability of A union B. So write the given values in this expression. So then becomes 1 by probability of A, how much? 1 by 4 plus probability of B, how much? 1 by 2 and A union B 1 by 8. So then take LCM here 8. So 4 2 and this is 4 minus 1. 2 plus 4 6. 6 minus 1 5. 5 by 6 is the required probability of A intersection B. So like this you can solve any problem related to additive rule. Similarly, we go for the last and next problem, that is problem number 4. In problem number 4, the given data is probability of A equal 1 by 3, probability of B equal 1 by 4 and probability of A union B equal 1 by 6. Then find probability of A intersection B complement. A intersection B complement. Now this we can write as probability of A intersection B complement. This is equal to, from the set theory we can write, because from set theory we have one rule. Probability of A complement is equal to 1 minus probability of A. Similarly, probability of A intersection B complement equal 1 minus probability of A intersection B. Now, similarly, you hear 1 minus, 1 is a number, minus is operation. Probability of A intersection B, you write this value from the additive rule. So, probability of A intersection B, how we write? Probability of A plus probability of B minus probability of A union B. Now substitute all values, like in example or in problem number 2. So 1 minus bracket probability I have much? 1 by 3. Probability of B how much? 1 by 4 minus 1 by 6. Now simplify this. 1 minus big bracket, take LCM. So what happened here? LCM. Now this becomes here 12 LCM. So 3 4 ja plus 4. Now here this becomes 3 and this becomes here 2. Now what happened here? 1 minus bracket 4 plus 3 7. 7 minus 2 5. 5 by 12. 5 by 12, again you take LCM here 12. 12 minus 5. This becomes 12 minus 5 how much? 12 minus 5 is 7. 7 by 12. 7 by 12 is the required probability of A intersection B complement. A intersection B complement. So these are the some problems I have solved with the help of the additive rule. So thank you so much. We will meet again in the next lecture.